Hello there. I'm sorry if I'm a wee bit nervous during this. I don't like public speaking too much, but it's a great opportunity to get to present this for you. So, my name is James Williamson, and I am the GIS specialist for the Nunatsiavut government in Northern Labrador, and I'm here to present on our use of QGIS in lands management in Nunatsiavut Labrador. Now, a wee quick introduction. So, my name is James Williamson. I'm originally from Northern Ireland, and I'm a PhD candidate in archaeology at Memorial University of Newfoundland and Labrador, specialising in geostatistics and remote sensing within central Newfoundland. My position focuses on providing geospatial capabilities for the Nunatsiavut government in Northern Labrador, whose land claim is based on the 2004 Labrador Inuit Land Claims Act, and this is going to kind of circle back to this. I'm going to issue talking about Indigenous issues and focus on the difficulties that are kind of present in working in Northern Canada, that hamstring some technologies. Now, to kind of get a look of where this is the view of Northern Canada, right? And this is the Inuit lands on the left here, and you can see the little area there that's highlighted in green over on the bottom right of that, and this is on the right there, you'll see the area that I'll be discussing. Now, the Labrador Inuit Land Claims Act, it defines the use of land within the brown area and the dark green area, and this is the Torngat National Park, and the brown area is the Labrador Inuit settlement area. But in particular, I'll be focusing on the bright green spots, and these are the Labrador Inuit lands which are fully governed by the Nunatsiavut government, the Labrador Inuit government, that is. Now, to get a look at what I'm going to talk about, I'm trying to pack in a good bit of information here into a short amount of time, so there might be a wee bit of cutting short in some bits. Originally, we used ArcGIS Pro, but we had to look again at the technology we were using due to a few issues around connectivity problems and open geospatial methods and file types. And the final point that pushed me towards using QGIS for this was the graphics possibilities. Now, then I'll talk a wee bit about the projects that I've been working on, and then I'll go on to the challenges that I've faced in terms of getting QGIS to work to its fullest within the processes I have to work on, and finally I'll look at the future goals within the GIS use in Nunatsiavut, and I'll have a few concluding remarks. Now, there are three main problems that led to the adoption of QGIS. The first was internet connections and connectivity. Most of Northern Canada and a lot of the Northern world suffers from really poor internet connections, and I know that in some cases my office had an internet speed of 6 kilobytes per second, which meant that I couldn't log into ArcGIS Pro at times. But this isn't just a problem with ArcGIS Pro, it spreads throughout a lot of closed source software. AutoCAD and the Adobe software suite often require regular logins, even if you're working offline. It's just to protect their digital rights and all that, and it's understandable. Now, there are plans to get better internet for Northern Canada, particularly Nunatsiavut and Nunavut. There's supposed to be a subsea cable being put in from Greenland and from Denmark, but again, this is in the early stages, and it can't be counted on for a good while. So that meant that I had to make choices that would be centered around open source tools that would work in a fully desktop sense whenever it came to the main processes. And while the ArcGIS focus created these issues, it meant that we had to look elsewhere in the future. Now, the next set of issues that kind of led us away were the open file types and the open methods. Esri shapefiles and geodatabases made up the majority of our files, and they worked quite well for some of the time, but the prior GIS specialist had switched over from ArcMap to ArcGIS Pro, which broke our file connections and meant that geodatabases could no longer be used. In a lot of cases, MDBs were no longer the thing that the Esri software used, and they were now inoperable. Other files were lost because the file link was broken. Now, this created a situation where we needed to look at how we were storing data again, and I decided that a couple of geodatabases could be looked at as the best possible options. My first choice was GRASS. However, GRASS-GIS had some difficulties in producing the correct type of layout that I was looking for. There's specific forms to be fulfilled whenever you're producing something that works through different layers of government, and it has to look like what came before. Now, the other thing was that while it has a brilliant database system and it's very stable, it has trouble loading, or it had trouble loading large files, like large numbers of toponyms, say 7,000 toponyms might not load in it. And like whenever you're working with a large database of places, it becomes quite difficult. But the next choice was QGIS, and I found that was able to use GPU acceleration, and it also works pretty fast, which allowed us to visualize the whole areas of data set that we needed. And it also meant that GeoPackages became the next choice. In terms of the normal use cases, these are essentially just spatial tables which are SQL enabled in the functional sense. And that meant that they were able to work across the different areas that we needed to work across, like specific types of files have to be stored together. Legislative data has to be stored alongside other legislative data, while applications for land use have to be stored together. And it also meant that I could pull apart different file types for easier sharing across groups. And the final issue that had led me to QGIS was the fact that they have a mature and capable layout system and a good system for graphics. I've been particularly using the expression builder, and this has allowed the advanced labeling functions that are necessary for working with a whole set of different applications. Well, different applications as in land use applications, and it also meant that the labels could be produced in a way that would show the different types of data that were necessary for other users who primarily focus on paper-based maps and needed to see coordinates and so on. The expressions also allowed me to automate a good bit of the production of the layouts, and we'll see one of those later on. Now, in using this, I've used it with three main projects. I've used it with the Labrador Inlands Lands Misalignment project, which was a long-running issue, with managing the spatial database itself, and also with visualizing drone data of specific areas. Now, the legislative land parcels are designed are described in the legislation as a set of points defining inland areas and inland corners where they are, and then following the coast or following the land. And the areas where they followed the land no longer lined up with raster or with the current maps. They aligned with the historic raster topographic maps, which were used from 1948 until 2005, and which were the Natural Resources Canada data set that they were based on. And they're written into the legislation as the National Topographic System, which is still in use, but it's now a vector file. And the vector file is now at an appropriate standard. And this is one of those issues of authoritative data sets where the Natural Resources Canada do not say that the data is authoritative in terms of how it defines the landscape, but they do produce it, and it is specified in the legislation, which creates a situation of authoritative accurativeness, or close enough to it, although it is regularly updated, which is an issue that I'll be mentioning later. Now, there were a few solutions to this problem. You can see up there in the map, there's a slight misalignment. Now, I wanted to capture a large enough area to kind of show this, but that's a 60-meter misalignment of the coast and of the parcels because of the difference and the warping of the old paper-based maps as they were geo-referenced. And when compared with the vector data, this is quite a big difference. So the original solution was to work through a Procrustes method that my predecessor had used, a stretching method, but this would deform the coordinates which had been defined in the legislation, which meant that it wasn't possible to be used because these are set in black and white, but it might have allowed it to match the coastlines, for example. Now, my original solution had been to look at the Natural Resources Canada tool for this, which was a JavaScript file which hooked into an early noughties version of OpenJump. I think that a lot of us have used OpenJump, but it doesn't work anymore. There's no handle for it anymore in the current versions of OpenJump. But again, it would have meant warping the interior coordinates. So in terms of working back through this, I came to the conclusion that a regular expression-based method to grab the coordinates using R was the best solution. And in doing this, I had to first of all grab out the text from the files using UB Mannheim's wonderful Tesseract OCR tool. And I grabbed out the whole text, and then I created a set of coordinates and used QGIS to then trace these so that I would, change these over the lines and then use QGIS to trace the coasts. But again, this is a point where I'll be discussing it later. And my goal in this was to create a workflow which was replicable, and I could send out to other people and they could see exactly where the data is coming from, because these are important for various industrial uses as well as personal and commercial land use. The big thing from my bosses was that the amount of land had to match the previous data set. It had to be the same amount of land. My focus was on matching the coordinates and matching the coastline. So I came to the conclusion that one possibility was to allow for a 5% change in the amount of land total, as long as it held to the legislative descriptions of it aside from that, and everything fell within those boundaries. So I was able to use this and work on with the backlog of files from coastlines in areas that you can see where it doesn't quite match. We've got a lot of applications for land use, and it allowed me to work on those. The next project is the Labrador Inlands Lands Database. This is all of the land applications, all of the permits, and all of the tenures that are governed by the Nunatsiavut government. And it's the central role it's the central duty of my position. This involved taking, basically, we get sent in points, we verify the points, and then we create a map like the one up there. And this is a very specific form because it has to look like the original ArcMap files that were produced with name, coordinates, and the toponyms of the areas around it. The toponyms are central. People know the land according to the specific names it's been given, and there's a lot more land use, so there is, than you would expect for such a low population area. In particular, this has really benefited from the labeling engine in QGIS because it allowed me to simplify out a number of tasks in ArcGIS which had required tasks to be developed, and it allowed me to just turn these into columns on their own, or for example using strings and concatenation to create them. And it also allowed me to set up more intelligible labels for the CRS and the datum that were used in this. It's still an ongoing process, and I'm still always working on the base map for this because I want it to look good, which is a difficult sort of view to take, given that it has to be an official map that has to look something like a surveyor's map, and it has to have a formal look to it. Now, to follow on from that, the third set of projects, drone mapping tasks. So I'm going to talk about two different drone mapping tasks to kind of illustrate how we're just using QGIS as the visualization for these, and to kind of show some of the fun tasks that I get to do. So as part of my job, I get to work with outside researchers, and in this case I got to work with Emma Gilheeney on her research at the Hopedale American Army Base. Now, to kind of point out where this is, you can see there just about the middle of the coast where Hopedale is, and this has an American Army base overlooking the town. Now, this is a historic early warning radar station, and it's part of the Pine Tree Line. She was particularly looking at community-based initiatives in the area, and the memories that people have of living in a town that had a bunch of American soldiers in it, in an Inuit town. And the method that we followed for this was to use a Mavic Mini to fly a photogrammetric flight over it. I know that a Mavic Mini is a bit simple for a lot of things like this, but it really sort of suited the needs of this low-level flight over the area. And we produced the 3D model. We used Agisoft Metashape, but in the future, in drone mapping applications, I want to use something else, either Micmac ENSG or Meshroom or Open Drone Map to replace this, to make it a fully open workflow. And the mapping was carried out afterwards in QGIS. Now, for archaeologists, you've got to understand that the main data product is typically either the digital elevation model, or in this case, the orthophoto, which allows for a nice picture and a nice way to sort of visualize the site. And you've got to, I was working towards the goals and the standards of her work. But I found it quite interesting and allowed me to get out of the office. But the second of these follows more closely with lands management. So, to begin with, I just want to point out where the area is. Hebron is the most northerly one of those points. It is a former resettled community. So it is basically in the 1950s, prior to the 1950s, a bunch of people had moved there alongside a church and a church complex, alongside a Hudson Bay Company outpost. But in the 1950s, they were forced into the other communities. And a lot of people have deep connections to this area and strong cultural connections. So they're looking to build cabins up there to get a foothold so they can go further north to areas where their families would have hunted or fished. And in order to do this, we needed to get an accurate view of what was actually on the site. In this case, I went up with a drone and an MLID RS Plus, a simple RTK setup, in order to take enough points to georeference the drone data and to record where the features were, and to kind of get a look at this area. You can see the applications that are in this area, all the dots. And I mean, it's a very small area, and we're going to have cabins overrunning each other if we don't properly map it out and get a good idea of what's there. And it's very nice looking as well. I just wanted to kind of show the area. You can see the church there in the centre of it, so you can, alongside some Nunatsiavut government buildings that are used as sort of travel points for people. But my goal is that I want to pick out an open source photogrammetric method in order to process this, so that it can have a full open method and be used in the future by other other projects and by whoever follows me in the post. But to kind of just summarize, I mean, the projects have all focused on either managing databases or using QGIS as a visualization tool, and it's really helped with that. So it's allowed a lot easier handle on labeling, for example. Now, to kind of move on to the challenges quickly, and I'll almost be breezing through this. There are three difficulties. There's working with the expression builder, automating the system using the expressions, and attempting to find a good method for sharing data online. The expression builder, the biggest problem I've had with that is the lack of documentation, the lack of cookbooks or sort of step-by-step led documentation. Some of the tools are well and truly hidden, and it's easy to get yourself caught up in using the wrong tool. In my case, Coalesce was the best function. And I used that for the labeling, but I was originally suggested to use the array aggregates tool. The next step after that is the difficulty in selecting layouts immediately after selecting points from the map on the layout. And this has created a bit of an issue that I've been working through, because it would allow an easy, almost GUI entirely, automation of the system. And then finally, the last issue is we need a good method for sharing data inside and outside. And I mean, in a lot of cases, I want to work offline because of the slow internet connections, but I do need to start using web apps for this stuff. I need to open up some of the data, and that's a difficulty. So it is. There's a lot of closed data, but there is some of it that should be opened up for other people to use. Finally, the future goals. So the main goal in the future that I have is to automate the GIS component of the land use decision-making system so that other people in my department can use it on their own, and to simplify down the QGIS tools that I'm using. And then finally publishing the LILCA parcels, that geospatial data, along with a method. There are still 3 other types of land parcel that I'm looking at: water lots, specified material lands, and LISA overall. And I want to use our notebook with RSpatial to automate the creation of these features so that it can be shared on GitHub or something similar. And finally, I've been trying to put together slowly a common base map for the organization, and I hope to be able to share it online and offline. Because other base maps like the OSM work really well. However, they're focused primarily on population centres and infrastructure rather than the specific toponyms for areas that are used by local people in this case. And I want to kind of get this shared, and so that these can be more widely used by people living up there. And kind of in conclusion, I've tried to rush through a pedestrian sort of tour of using GIS in the Lands Division, and I think the main point that I would like to draw out is the fact that I'm still working on getting a good, stable system for this, and I'm working towards the goal of having an automated system that other people can use as well within the government, and it's still an ongoing process. And I'll just finish up with the view from the other side of the hill, looking out towards the landscape. Any questions?
I'm curious about, all maps we see are using English, and I'm wondering about internationalization and the syllabics that people use. We are creating maps in those formats, and does QGIS support that?
Oh, the difficulty of using internationalization and the syllabics used. Well, commonly there's 300 known toponyms in the data set that are in Inuktitut, but they're all in Roman letters rather than syllabics. And I believe that that's a step I'm going to have to cross whenever I get to it, because I mean, there's work ongoing in terms of like the large level translation of all of the toponyms, but there's 7,000 toponyms, so there are, and it'll take a wee while. And as well as that, working with OSM data is brilliant, don't get me wrong, but they're still using some of the place names from the Nunavik rather than the Nunatsiavut dialect of Inuktitut, and it means that there's some differences there in the language. I think my big focus would be, first of all, to get them in Roman letters, and I know though that there are specific lettering codes for the syllabics though, and hopefully someday. Next.
Have you looked at saving layer styles and project files into the geo package? Because it sounds like that would be a good way to go, especially with low internet in this situation, to share all in one file and everything.
Have I looked at saving the style files for the layers into the geo package? Yes, that's an ongoing plan. I really want to look into that, and I really want to try it because it seems like a good way to share the data without relying too much on an internet connection, and it would allow common styles to be shared throughout the organization. In fact, actually, we discussed this yesterday, and you mentioned that there are ways of translating styles in case anyone is a holdout for ArcGIS, so that I could even translate it over to their styles. It'd be, yeah.
Have you thought about setting up a QGIS server for local use by your government so that you can come and share the things? It sounds like you're moving geo packages from computer to computer or on a local area network.
Have I considered using PostGIS server instead of using geo packages?
Yeah.
I have, and it's one of the things that I'm going to be looking into in the future. It's one big issue is that sometimes even between the different communities, it's difficult to load files on the local intranet. We're working with a bit of a slow internet setup. Sometimes I'm almost tempted to try and work entirely through desktop tools and through desktop shared files, and that's why I kind of selected geo packages, because everything can be packaged up and it can be opened by almost any software. And even without having touched on the different servers, it can work. Aye. Is that anyone else?